Good morning, mathematicians. This is Mrs. Urano, and we have another installment from Chapter 9, Statistics. What you'll need for this lesson are a pencil and perhaps some colors if you want to do that. I won't do a ton of colors today, but it's always nice to have. You'll also need a calculator. I'll be using my graphing calculator, but even a calculator on your phone should be fine. And you will need your note sheet printed out. And lastly, remember last video I was talking to you about this information here, and then I started drawing the box plot, but the video camera couldn't see it because I forgot to move the paper up. Well, we are going to redo that box plot really quick now. Box plots are actually technically part of this section 9.3 in our textbook, so you can take a look at that there. So I'm just going to quickly review it now because they're pretty darn straightforward. So looking in my notes from yesterday, or last class, I can see that we had certain information. So when we're making the box plot, I will move it high enough now. The key thing is that the box plot, box and whiskers, shows us about where the data falls on the number line. So this number line is from 0 to 40, but actually the class sizes that we were looking at, the minimum class size is only 19. So you could do a little line at 19. I like to make it more of a dot though. Now the maximum is going to be, the maximum class size was 32 students, so I'm going to put a dot right there. So all of our data is going to fall in between the maximum and the min. No data was down here and none of it was up here. And then next we want to look at the three quartiles. So the first quartile was 23.5, so it's going to be halfway between 23 and 24, and I like to make a little line. The middle quartile, Q2, which is also known as the median, was 26.5. So that's right here between 26 and 27. And then lastly, the third quartile is 29. So we can connect these three to make a box. There's our box. That's where the middle 50% of the data fell, between 23.5 and 29. And then we're going to make our whiskers going out here. So that's our box and whisker plot. 25% of the data fell in here, 25% here, 25% there, and 25% there. This is Q1 you could label, Q2, Q3, min, max, and that's what a box plot shows you. It doesn't tell us where exactly this 25% of the data falls. We don't know if these values were actually all right around 24, or if they were all right up near 26, or if they were evenly spread out. So that detail is missing, but it can tell us a good amount about the data. Just a quick visual for where the data falls. All right, and in contrast, some box plots could look, it might have the same center 50%, but the median might be over here, indicating that actually all 25% of these data points are all really clustered in here. And it might only have a min that only goes this far, but the max might have a big tail, a big right skew going all the way out to a really big number. So that's kind of how you can compare box plots. Let's move on to today's note sheet, which is about mean absolute deviation, which we abbreviate MAD. No, don't get mad. It's not too bad. I'm so funny. All right. So mean absolute deviation. So you know deviation, you know what that means kind of colloquially in everyday language? It means how far you are away from the norm or from the middle. And to deviate, which is the root word, is to depart from the established course, right? So if we're going this way and we deviate from the middle, then we're going to the side somehow. And so that's what the deviation implies. And absolute, remember we've already learned about absolute value. We indicate it with two lines like this around a number. And it pretty much it means the distance of the number from 0. So in this case, we're going to be looking at the distance of the number from the mean, actually, from the average. The average is another word for mean. Okay. And so in conclusion, the mean absolute deviation is how far away, that's the deviation part, how far away. On average, that's the mean part. All the values are from the middle. And the middle is also the mean. So Yeah. Okay, so what does this mean? If we have a small mean absolute deviation, then that lesser value means that the closer the data values are to the mean of the data set. If it's a small MAD, then the data is pretty close. It's not very far away or spread out. But if the MAD is kind of greater, then that means the data is farther from the mean of the data set. So this is not a measure of central tendency, it's a measure of variation, this MAD that we're going to talk about. This is our main note page talking about it. There's one more where we're going to calculate it ourselves as well, one more practice problem over here, but really it's going to be short, and this is going to be our main first example, which has the steps really nicely laid out. This is how to calculate the MAD of data. So here's an example data set. We want to calculate the mean deviation of, and notice the A part is left out, but that's okay, it's the same thing. That's another way to call it, the mean deviation. And we have some data points here. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers there, so our sample size is 8. And the first step is to find out what normal is. We're talking about how much we're deviating away from the norm or from the middle. So the first thing is find out what that normal is. So the way we do that is we calculate the mean of the data by adding up all the data points and dividing by the number of numbers. That's n. So you can see here all the data points, and they happen to already be in order, which is convenient. They're adding all of them up and dividing by 8. I love this middle step here that's shown where the total of all the data points is right here, and then n is below, and then you have your final answer. This is very convenient. This is an integer answer, but if it wasn't an integer answer, say it was 9.33 repeating, then you would want to round it, and how exactly you round it makes a big difference. So I'm going to say for our course, unless otherwise stated, it's okay to round it to the nearest tenth. Your answer is not going to be as exact, but that would be okay. Okay, step 2 is, I lost my screen, where are you guys? All right, so step 2 is to find the deviations. So now we know what the middle is. The middle is 9. And in fact, this actually would be a really good time to talk about this picture here. I don't believe your textbook has any pictures that look quite like this, but I found this online, and I think it is a fabulous way, and I could be wrong, it might be in your textbook too, but I think this is a fabulous way to understand what is actually going on here. So what we have, let's take a look at it. What we have is these 8 data points that are actually all plotted here. So we have 3, which is right here. You can see that's 3. 6. We have 2 6s actually. So here's the 6, and here's 1 point, 2 point. Those are 2 6s. We have a 7 and an 8. The 7 is right here, and the 8 is right here. And then we have 11, boop, 15, boop, and 16. So those are our 8 data points, those 8 blue points there, put out on a number line where the number line is evenly spaced. And we calculated that the mean is 9, so this image actually already has this big fat line right at the mean. This is the norm, or the normal, the mean of the data. And so now what we want to calculate is, on average, how far are these data points deviating from our mean? So first we'll ask how far is each point deviating from the mean. We're going to find the deviations. We're going to calculate the distance of each value or each data point from the mean. So we're going to take the data point, subtract the mean, and that's going to tell us the deviation. And we're actually also going to be able to take the absolute value of that. Okay? So we're going to kind of ignore the negatives. In other words, we're not going to care if it's 3 to the left or 3 to the right. We're not going to worry if this 3 is 6 under 9 or 6 over 9. We're just going to say the distance from the mean is 6. Now, I think I'm actually going to draw this out a little bit longer since this is our first time doing it. So what we're going to do is we'll start with it doesn't really matter if you do this minus this or this minus this actually. It will be the same difference. But let's do the data point, which in this case is 3. I'm just going to repeat the data points here. And then we're going to subtract the mean. So we're going to subtract 9 from all these. Now, if you made a miscalculation on what the mean is, that means all this is going to be wrong. So you want to kind of make sure you did that correctly. But showing your workout is wonderful, because say you later figure out you miscalculated it and it should be 8 instead, it would be easy to just turn all these 9s into 8 and then recalculate from there rather than having to do it all over again. So showing your work is always valuable. So the distance from the mean here, this is 6 under the mean. This data point is -3. It's 3 less than the mean. This one's also 3 less than the mean. This is 2 less. This is 1 less. This one is 2 over the mean. This one is 6 over the mean, and this one is 7 over the mean. So these are their deviations, but remember, we're going to be able to look at the absolute value of the deviation. So it doesn't matter that this is 6 to the left. We're just going to say it's 6 away from the mean. 3 away, 3 away, 2 away, 1 away. And then this is 2 away, 6 away, and 7 away. So these are our deviations that we're going to use. The absolute value of the deviations, you could say. So we can actually really see that in our diagram, which is so pretty. This is how we actually calculate it using this formula right here. But now this is what it really means. We can see that 3 and 9 really are 6 away from each other. We can count 1, 2, 3, 4, 5, 6, right? We can actually see all these little arrows in here represent the deviations. So I'm going to maybe make a note here like this. All these arrows are the deviations from the mean. That's always the implication, from the mean. You could even write that if you wanted to. So that's our second step. We found the deviations. Now our third step is that we want to know the average of all the deviations. So I'm looking at here, this one's 7 away, 6 away, some are just 1 or 2 or 3 away. I'm going to maybe guess that the average of these points is somewhere around 3. Or maybe 3.5. That's going to be my guess. Actually, we can see right down here, I just looked down here, 3.5 is a pretty good guess. It's very close. But here we go. The way we do step 3, that we find the average of all these deviations, is the same way we always find the average. We add up all of the deviations, the absolute values of them, meaning this column. We don't want to add up this column because then these numbers will be subtracted from these. We'd get a really small number, and it'd actually be a negative number. We want to add the absolute values of the deviations. And then we divide by the number of numbers, which is n. So we would divide them all by 8. Our total was 8. Our n was 8. We have 8 data points. We also have 8 deviations. And our answer to this is going to be the MAD. So let's take a look. We're going to go ahead and add 6 plus 3 plus 3. That's 12. 13, 14, 15, 16, 17. 17 plus 7 more is 24, plus 6 more is 30. Okay, so we added up all these, and actually, I just saw they did it for us down here. They added up all those data points, and they got 30. Again, note the middle step shown. This is the total of the deviations. And then we're dividing it by 8 because there were 8 numbers altogether. This is the average. This is the average of the deviations from the mean. The mean of the deviations from the mean. Okay, that is what MAD is. If you also wanted to look at this link here, I got a lot of these images from this site because I thought it was just such a beautiful representation. I try to pull from other resources when I think it'll be really helpful for you guys. Okay, so on average, these have a deviation of 3.75. These data points here. Now, if the deviation, let's say we did all this work to calculate it and our answer was just 2. Let's say that the data was different and the mean deviation for that data was only 2. That would mean, if we were looking at a number line and this was the mean, that the data points were pretty close to the mean. As opposed to this data, which is, I can maybe do that in a different color. This data is much more spread out from the mean. We've got points kind of way over here. So its deviation's a little bit greater. Say the MAD was actually 0. Let's say the MAD was 0. What that means is that there is no deviation from the mean. That means that every single data point was the same. So let's say 6, 6, 6, 6, 6. Okay? All these data points have no deviation. The mean is 6, and none of them deviate. Okay? So hopefully those kind of examples help. Students, I am so excited to help you develop your mathematical thinking. All right? So you could just be human calculators that know how to calculate this number and get it, but don't really understand what it means. But the truth is that calculators are actually dumb, folks. They can do amazing calculations, but they don't know how to interpret their calculations. And they only know how to do calculations that you put in. So if you put the wrong numbers in and actually add up these negative numbers, you're not going to get 30 if you add these up. You're going to get a different answer. Or if you accidentally do your subtraction wrong, get these numbers wrong, your calculator only knows how to do what you put into it. So long story short, what I'm trying to say is we are developing our mathematical thinking by really visioning what's going on and really kind of thinking about and understanding what that means practically. All right? So that is my lesson. We are also going to do one final example that I help you with, but and that's going to be a part of our notes, so please go ahead and let's do this. If you'd like, you can pause it. This might actually be a great time to pause the video in a moment. I'm just going to point out right now that these are not yet in order. So if we wanted to calculate the median of these, we can't just look to the middle like this. These are not in order, so we need to get them in order yet first. So let's go ahead and actually put the data in order. I can see that we have a 2. We have a 3 and a 3. We have a 3.5 and a 4 and a 5. We have a 6.5, a 7, and 2 eighths. Okay, did I miss anything? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I purposely gave you 10 boxes. All right, so let's see if you can go ahead and go through all the steps that we did on the first page to calculate this yourself. If you think you can do it, why don't you go ahead and try? And then you can actually fast forward a little bit in the video. But if you still really need my support, that's fine. I've only done one example with you so far, so I will go ahead and do this with you now if you don't want to pause. All right, so step 1 is to find what the normal is, to calculate that mean, this big bar in the middle. So we're going to calculate the mean here. We're going to take all of our data, and actually this already says sum, so we're going to add this up. Get out your calculator and see if you can get the same answer that I do. 2 plus 3 plus 3 plus 3.5 plus, and now for 4 and 5 I'm just going to put 9 and then keep going. I like to do that every once in a while. For 8 and 8 I'm just going to do 16. So we add them all up and the sum is 50. So that means that the mean, I'm going to write this really big somewhere, the mean of the data. Now this is actually good to specify. We're talking about the mean of the data here, not the mean of the deviations. So the mean of the data is going to be this total of the data, 50, divided by the number of numbers, which is 10. So the mean is going to be 5. All right. What next, guys? After we find the mean, we want to calculate the deviations. We want to know how far away are these numbers from the mean. So this number 2, we're going to do 2 minus the mean. That number's 3 away. Now I can even be lazy and just write 3. Technically it's -3, but the actual absolute value of the deviation is just 3. So let's see, am I really going to teach you that you can be lazy? I'm going to write it out the full way here, but in your brain you might be able to do kind of the shortcut way. So this data point minus the mean, this data point minus the mean, this data point minus the mean. These are all negative numbers here, but here, this data point is right at the mean, so that deviation is nothing. And then these data points are to the right of the mean, so we're going to be getting positive answers for these. So we'll go ahead and say this is 2 away. This is only 1.5 away, right? This one's only 1 away. Now notice, since we've put these in order, from smallest to largest, the deviation away from the mean is going to be getting smaller and smaller and smaller. And now these data points, since 5 is the mean, are actually going to start to get bigger and bigger and bigger. So that's another way to use our critical thinking and to be able to check whether our numbers are accurate or not. These should be in descending order as it gets closer and closer to the mean, and then these numbers will start ascending and getting larger again as we get away from the mean on the right side. Kind of cool, right? Your textbook doesn't mention stuff like that, but I really like to point it out because it's helpful. All right. 7 is 2 away from the mean, this is 3 away from 5, and this is also 3 away from 5. So I skipped those calculations. All right, so these are our deviations, and now we're going to write the sum of all of these deviations. So the mean of the deviations we'll be able to calculate in just a moment. If we add all these up, let's see. We have 3 plus 2 2's plus that plus, I'm taking some shortcuts here. Never mind. I'm just going to do it all in one line here. 3 plus 2 2's plus 1.5 plus 1 plus 1.5 plus 2 and 3 is 5 plus 3. So I did a little shortcut there in my head. And I get the total is 19. Alrighty. So that means that the total of the deviations is 19, and in order to find the mean, I'm going to divide by the number of deviations, which is 10. So the mean of the deviations is 1.9. Cool? That is our MAD, the mean absolute deviation. Should we check to make sure? Let's go back to our other sheet. Do we do all of our steps? Yep. Your answer to the step 3 is the MAD. It's the average deviation from the mean. Excellent. We did all of those different steps there. And lastly, in terms of really understanding what this means, and I'm going to go ahead and write it down here again so that I can move my paper up and I still see it. Doot, doot, doot. What is the meaning of the mean absolute deviation? Again, it indicates how spread out the data is. So if we would actually plot our data points here, you can see that our data points were, I'll read them off to you. The first data point was 8, so that would be over here. And we also had a 2, and we had a 3. I'm going to put them up a little bit just to help us. We had another 3. We had a 3.5. We had a 4. We had a 5. And then this is the mean. So we also had a 6.5 and a 7 and an 8. So let me just make sure I have 10 data points. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, I missed one. What did I miss? We had 2 8s. That's what I missed. Always good to check. So you can see this data point is 1, 2, 3 away, and that's what this 3 here means. This data point is 2 away, and so is this one 2 away. That's what these 2 deviations of 2 mean. This is 1.5 away. This is 1 away. This one is not away at all. This one is 1.5 away. So do you see that? This is 2 away, and these are both 3 away. So it's really these deviations, these arrows that I drew, which is this column here. So these are all the arrows, all the deviations. I hope that makes sense. I'm going to leave the video at that and let you go on to, I'm calling it homework 64, 65, I believe. But it's assigned for the same day because this is a short video. And I want you to be able to go right away to applying this knowledge, both of how to do box plots, like this, and of how to calculate the MAD. So good luck, folks, and please, please, please contact or email me if you have any questions. I would be really happy to hear from you. I mean that very, very sincerely. Okay? Have a great day.